Let's look at an example where we are simplifying an expression with rational exponents. So, for example, x to the 1/3 times y to the negative third power all over x to the 1/2 power times y to the negative fifth power times x to the 1/4 power. So first, I notice that in my denominator, I have two expressions with x as the base. And so I can combine these using one of my laws of exponents. When I multiply things with the same base, I add the exponents. So here I'm going to get x to the 1/2 plus 1/4, which is x to the 3/4 power. So now I end up with x to the 1/3 times y to the negative third power over x to the 3/4 power times y to the negative fifth power. And I'm going to use another law of exponents where I'm looking at dividing expressions with the same base. Here I have x to the 1/3 divided by x to the 3/4, and I'm going to subtract my exponent. So I will end up with x to the 1/3 minus 3/4. And I'm going to do the same thing with the expressions with y as the base. So y to the negative 3 minus negative 5 power. So I've got my expression that has x as the base, and I need to subtract 1/3 minus 3/4. I need a common denominator. I'm going to use 12. 1/3 converts to 4/12. 3/4 converts to 9/12. 4 minus 9/12 is negative 5/12. So I have x to the negative 5/12 power times y to the negative 3 minus negative 5 is positive 2. And when we have negative exponents, we don't like to leave negative exponents in our final answer. We like to have final answers with positive exponents. But remember, negative exponents, I can move the position it is in a fraction, or x to the negative 1 is 1 over x to the positive 1. I'm going to form the reciprocal and change the sign of the exponent. So my x to the negative 5/12, I'm going to write a fraction bar and put that in the denominator, but change the exponent so that it's no longer negative 5/12, but positive 5/12. And y squared is still in my numerator. So this is my end simplification. Y squared over x to the positive 5/12.